This is our Zooniverse project. Our project's name was Citizen ASAS-SN. Presented by Ashley Quiñones, Crystal Garza, Brittany Montenegro, Lillian Williams, William Martinez, and Celine Bogg. Citizen ASAS-SN stands for the All-Sky Automated Survey for the Supernovae. It is the first and only project that takes images of the entire visible sky on a nightly basis.
The goal here isn't an all-inclusive one. We need to identify, categorize, and help expand the knowledge of variable stars by analyzing the changes in brightness over time to understand the life cycles of the twinkling lights that we know and love. Answering these questions will advance scientific knowledge by providing well-informed data on the variable stars to those who are also questioning it. That way, those who are and are not scientists who are trying to figure out what type of variable each star is can refer to the research that scientists have already sought.
In the Citizen ASAS-SN assignment, you classify stars based on their light wave patterns into 4 categories: pulsating variables, eclipsing binaries, rotational variables, and junk. The intent of this program is to allow humans to recognize and classify light waves from stars, identifying unique characteristics that a machine/computer might oversee. Here are the examples of the 4 categories: eclipsing binary, pulsating variables, rotational variables, and junk. I want to say that this task was 50-50. Some tasks came easily to me, while others were very confusing. This task was interesting and fun to participate in. It was nice to see how different branches of careers have their own unique way of doing projects. What I enjoyed most about the project was learning about citizen science, the different activities, and different events that it involved. It was very interesting to learn about oceanic services and read about citizens volunteering for them. I think my only complaint and least favorite thing about this task was having the confidence that I was classifying these variables accurately, which was not the case. I was actually surprised by some of the citizen science articles/programs that were published because I learned about the different activities they have. I thought it was very interesting. I want to say that the only confusing part for me was accurately labeling 2 variables, pulsating and rotational. They tend to look very similar.
The work was more complex than necessary. It demonstrates that every student may become an astronomer by discovering new stars. I suppose the most interesting aspect of the work was listening to the stars' vibrational data sound waves. While I reflect, this adds excitement to Zooniverse. I enjoyed classifying like an expert. I am sure that was the same experience for everyone because it was exciting to know we were analyzing stars. However, analyzing between rotational and pulsating variables was the least fun because it was challenging to differentiate them. Calculating irregularities was complicated, yet it was staggering how much analysis went into the project.
The Zooniverse project was relatively easy and not very time-consuming. Initially, some reading was required to understand the different characteristics of starlight waves for proper classification. The task itself was interesting, and I enjoyed reading the talk tab from the data collected from other star classifications, although the only downside was not knowing whether my classifications were correct.
The classification task varied between being simple and complex based on the star type. Observing eclipsing binaries was simple because of their distinct brightness drops, but distinguishing rational variables from pulsating variables proved difficult because of their light curves appeared alike. Our participation in real scientific research made the task interesting since we gained practical experience in astronomy. The process became engaging and rewarding through the analysis of light curves and pattern identification. I felt like an expert when classifying stars and found fulfillment knowing my work supported astronomers. I found it most challenging to differentiate rational from pulsating variables due to their patterns being hard to distinguish, which extended the duration of the task. Researchers were amazed to learn that light curves provide extensive information about the attributes of stars. The patterns of brightness revealed whether a star rotated, pulsated, or existed within a binary system. The primary challenges lay in distinguishing rational variables from pulsating variables because their light curves displayed similar patterns.
This task was easy. Once I looked at the examples of different variable stars, I was able to classify the stars with ease. It was a bit interesting because I did not even know there were diverse types of stars aside from the sun. I just thought there's regular stars and the sun, but now I know that there is much more of a variety. I enjoyed most seeing how the brightness of a star can vary depending on what type of variable it is. My least favorite part was that sometimes it would not be confirmed whether my classification was correct. Something that was confusing for me was categorizing pulsating and rotational variables because they looked so similar. We delivered human analysis of light curves to the Citizen ASAS-SN project, which proved more accurate than automated computer algorithms. Through the identification and classification of variable stars, we delivered essential information to astronomers, which aid in studying the life cycles of stars as well as their interactions and brightness variations. Through citizen scientists' collaborative work, researchers can now handle greater data quantities and expand their knowledge about variable stars. Thank you for watching our presentation. If you have any questions or comments, let us know in the discussion board replies down below. Thank you.